Hi guys, welcome to this easy maths video, and today we will be looking at 3 different question 25 problems from the UKMT Senior Maths Challenge. So the problems I've got are from the 2014, 2015 and 2016 papers. So the first one's from 2014 and it says figure 1 shows a tile in the form of a trapezium where alpha is equal to 83 1/3 degrees. Several copies of the tile are placed together to form a symmetrical pattern, part of which is in figure 2. The outer border of the complete pattern is a regular star polygon. Figure 3 shows an example of a regular star polygon. So figure 1 is a diagram of a trapezium. Figure 2 shows a symmetrical pattern which is made up of a series of the trapeziums from figure 1. And then that symmetrical pattern makes up a star polygon which we see in figure 3. The question is, how many tiles are there in the complete pattern? So we've got answers as A is 48, B is 54, C is 60, D is 66 and E is 72. Okay, so I think the first thing to do with this question is to understand how these diagrams link. What you should be able to see is in figure 2, which I've enlarged here, that this is actually made up of several trapeziums from figure 1. If we zoom in, let's say on this trapezium, this is going to have an angle of alpha, this is going to have an angle of alpha, and therefore we can say the same for each of these trapeziums. And then what's happening is this symmetrical pattern, which is made up of each of the trapeziums from figure 1, is creating an outer border for the sides of the star polygon of figure 3. So basically, on figure 3, each of the sort of zigzag edges, which I've highlighted here, make up the outer border of the polygon in figure 3. If we look at each of the answers, we can see that each of our answers are even, so we know that we're going to have an even number of tiled patterns. So if we know that if we're definitely going to have an even number, we can represent this as 2n tiles. If we've got 2n tiles, then that means we have 2n edges and 2n internal angles. So if we focus in on this diagram here, what we can do is we can work out how many patterns there are from the interior angles. So we are going to need to find the interior angles of each of the connections between each of these shapes. So we know down here that this is an angle of alpha and this is also an angle of alpha, but we don't know what this angle is. So if we represent that with another constant, say beta, then what you should be able to see is obviously the bottom base of the trapezium is a straight line and the other angle that makes up beta is alpha. So therefore we can say that beta is equal to alpha plus 180 degrees. So we need to find the sum of all these interior angles. So what we know is there's sort of an alternating pattern. It goes alpha as the interior angle, then beta as the interior angle, then alpha as the interior angle, and up here we've also got beta as an interior angle. So what that means is n angles are going to have an interior angle alpha, so we say n times alpha, and n angles are going to have an interior angle of beta. Well, we can replace beta with alpha plus 180, so we say n alpha plus n all multiplied by alpha plus 180. And then if we take out this common factor of n, we're going to have alpha plus 180, which of course is n all multiplied by 2 alpha plus 180. And we've got a value for alpha. We know that alpha in the question is 83 1/3. So we do n multiplied by 2 times 83 1/3 all plus 180. So what I'm going to do is I'm going to rewrite this as a top-heavy fraction. So we do 3 times 83, which is 249, then add the 1, we get 250 over 3 plus 180. Then multiply that by 2, we're going to get 500 over 3 plus 180. Then we're going to have a common denominator of 3. So if we multiply 180 by 3, we're going to get n all multiplied by 500 over 3 plus 540 all over 3. And that simplifies to n all multiplied by 1040 over 3. So that's great. We've got the sum of all our interior angles, but we still don't know what n is. So in order to find out n, what I'm going to do is I'm going to form another equation for the sum of the interior angles. So what you should know from GCSE maths, if we have a polygon, let's say we've got a pentagon, and if we divide this pentagon up into 3 triangles, we know that each of those triangles have interior angles of 180. And of course, from that definition, we can say that the sum of the interior angles for a pentagon is 3 times 180. We can apply this same principle to any polygon, no matter how many sides it has. And what you should be able to notice here is that obviously a polygon has 5 edges, and it's made up of 3 triangles. So therefore, we can form an equation for any polygon. And we can form that equation by, let's say, if we use t for the number of triangles, multiply by 180 degrees. Well, t is equal to the number of sides s minus 2. So therefore, we can say that s minus 2 all multiplied by 180 will give us the sum of our interior angles. Now, at the start of this question, we were told that this polygon is going to have an even number of sides, and we represented that with 2n. So if we substitute 2n as s, so s equals 2n, we're then going to get 2n minus 2 all multiplied by 180. And now we have 2 equations in terms of n, which represent the sum of the total interior angles. So therefore we can make them equal to each other. So we can say that 2n minus 2 all multiplied by 180 equals n times 1040 over 3. Now what I'm going to do is I'm going to expand the brackets for the left hand side. So we get 360n minus 360 equals n all multiplied by 1040 over 3. And rearrange this so I get the n's on one side, and we get 360n minus n all multiplied by 1040 over 3 equals 360. And again, we've got a common denominator of 3, so if we multiply 360 by 3, so we get 1083n minus 1040 over 3n equals 360. That is going to simplify to 40n over 3, which is equal to 360. We can multiply both the left-hand side and the right-hand side by 3, so we get 40n equals 1080, and then we can divide both sides by 40. So we get n equals 1080 over 40. We should be able to see if we divide both top and bottom by 4, we get 270 over 10, and that of course simplifies to 27. So now we've got a value for n, which is 27. And at the start of the question, we said our sides are equal to 2n. So it's 2 multiplied by 27. So 2 times 27 is equal to 54. And if we look at our answers, we've got B, so therefore our answer equals B. Okay, question 25 from the 2015 paper. A function defined on the set of positive integers is such that function xy is equal to function x plus function y for all x and y. It is known that function 10 is equal to 14 and function 40 is equal to 20. What is the value of function 500? Answers is A is 29, B is 30, C is 39, D is 48, and E is 50. So what this question is basically saying is, as a function, the product of x and y is equal to the sum of x and y. So we need to find a value for function 500. Well, if that's going to be made up of the product of two terms x and y, could use function 10 is equal to 14 and then find a value for function 50, because 10 times 50 is 500. But we've also been given this value for function 40. And if we use the fact that function 40 is equal to function 4 times 10, then that's going to be equal to the function of 4 plus the function of 10. Well, we've got an answer for function 40, which is 20, so we could say 20 equals function 4 plus 14. And we could rearrange this to get function 4 equals 20 minus 14, which is 6. Okay, but function 4 doesn't really look like it can help us in any way. But from function 4, we can easily work out function 2, because it's going to be function 2 times 2, which is obviously going to be function 2 plus function 2. Well, function 4 is 6, and we've technically got 2 times function 2, and surely function 2 is going to be equal to 3. Okay, so let's see what we worked out. We know that function 10 is 14, function 40 is 20, function 4 is 6, function 2 is 3. Well, you should be able to see from here that we can work out a value for function 5, which is what we need to get to function 50, because function 50 is going to be function 5 times 10. So how can we work out function 5? Well, we've got a value for function 10. Function 10 is the equivalent of function 5 times 2. Function 10 is equal to function 5 plus function 2. Well, we know function 10 is 14. Don't know what function 5 is, but that's what we're trying to find, and we know that function 2 is 3. Now you can rearrange this to get function 5 is equal to 14 minus 3, which is 11. Now we've got a value for 5 and 10, so we can work out what function 50 is. So function 50 is the function of 5 times 10, which in other words is function 50 equals function 5 plus function 10, which is equal to 11 plus function 10, which is 14. And that gives us a value of 25. So now we know what function 50 is. So from there we can work out function 500, because function 500 is going to be the function of 50 times 10. So function 500 is going to equal function 50 plus function 10. And of course function 50 is 25, and function 10 we were given was 14. So therefore it's 25 plus 14, which is 39. If we look at our answers, C is 39. So therefore answer equals C. Okay, question 25 from the 2016 paper. Let n be the smallest integer for which 7n has 2016 digits. What is the units digit of n? Got answers as A is 0, B is 1, C is 4, D is 6, and E is 8. Okay, so this question doesn't give you a lot of information, but let's see what we know. So in other words, we need to let n be the smallest integer for which it has 2016 digits. Now, and you should know that the smallest number with 2016 digits would be a 1 followed by 2015 noughts. But of course we can't write that out. So we think how we would write 10. 10 is a 1 followed by a naught, so that's the same as saying 10 to the power 1. And 100 is a 10 followed by 2 noughts, so that's 10 squared. And then you could also say the same for 1,000, so it's 10 followed by 3 noughts, which is 10 cubed. So therefore that means if we've got a 1 followed by 2015 noughts, we can say that that should be equivalent to 10 to the power of 2015. Okay, but we're told in the question that it's not n that has 2016 digits, it's for 7n, which has 2016 digits. So what we're basically saying is that 7n needs to be at least, which is greater than or equal to, 10 to the power of 2015. Okay, and we need to find the unit digit of n. So we're going to need to work out a value for n. So if we divide both sides by 7, we're going to get is greater than or equal to 10 to the power of 2015, all divided by 7. There isn't any easy way in going about this, but the way I thought about it is, let's forget the power for a second, and let's pretend that this is just 10 divided by 7. And I want to work out as many digits of this number as I possibly can. So I'm going to use the bus stop method, and I'm going to add quite a few decimal places after the 10 because I want to get 10 over 7 as exact as I possibly can. Using the bus stop method, I'm going to say how many 7's going to 10. It's going to be 1, and then I've got a remainder of 3, which I'm going to carry over. So then it's how many 7's going to 30, which is 4 remainder 2. Then it's how many 7's going to 20, which is 2 remainder 6. How many 7's going to 60, which is 8 remainder 4. And then how many 7's going to 40, 5 remainder 5. Then how many 7's going to 50 is 7 remainder 1. How many 7's going to 10 is 1 remainder 3. How many 7's going to 30, 4 remainder 2. And how many 7's go into 20, 2 remainder 6. And then how many 7's go into 60 is 8, and then there's a remainder of 4. Okay, so that's what I'm going to go up to. So if I put my decimal point in, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. I've gone up to 9 decimal places. I could go even further. But what I've noticed is when I got to the 1, I ended up with the same remainder which I had at the start, which was 3. And if you can see, what I'll do is I will go a few more decimal places just to show you. So 7 into 40 is going to be the 5, remainder 5. And then 7's into 50 is going to be 7, remainder 1. 7's into 10 is going to be a 1, and then I get my remainder of 3 again. And then I'm back to how many 7's going to 30. So what you should see here is that if I shade in one colour the first few decimal places, and then in a different colour shade these decimal places, you'll see that 142857 is repeating every time. So I can write 10 over 7 is equal to 1.42857, 142857, ... because that's just going to keep on occurring. So what that means is I could rewrite this as 1 over 7, and I could move the decimal place 1 point to the left, and I'll get 0.142857, 142857, ... keeps on recurring, and we can write it like that. Now, here comes the clever part. Something that you'll notice is every power of 10, the decimal point will move 1 place to the right. So we've got 1 over 7 is 0.142857, 14287, and then we've got 10 over 7 where we've just move the decimal point 1 place to the right. So we want the value for 100 over 7, which is the same as 10 squared over 7. That means from 1 over 7, we're going to move the decimal point 2 places to the right. So it's going to be 14.2857142857 ... And then let's say if it was 10 cubed over 7, so 1000 over 7, we're going to move the decimal point 1 space to the right again. So we get 142.857142857 ... Now, what that means, well, if we're interested in what 10 to the power of 2015 is, then surely the decimal point is going to move 2015 places to the right from the value of 1/7. So that's good, because I can now say that 10 to the power of 2015 over 7 decimal point moves 2015 places to the right, which is correct, but how am I going to work that out? Well, I set up here when I was working out what 10 divided by 7 is, that we've got 6 repeated digits, which is the 1428571. So what that means is for the number 2015, we're going to have to work out how many 6-digit multiples we have until we get to the units column of n. So we can sort of write this as an equation. So we could say that 2015 is equal to the 6 repeating digits multiplied by the total number of repeating digits, we're called D. So I know that 2015 divided by 6 is not going to give me a whole number, it's going to give me a remainder. So I can rewrite the equation as 2015 equals 6D plus R. So D is my number of repeated digits, and R is my remainder. So now I need to try and find values for D and R. Well, that's easy because I can just do 2015 divided by 6. So I'm going to use the bus stop method. So I'm going to say how many 6s go into 2015. I'm going to include a few decimal places after this. So I'm going to say how many 6s go into 2. Well, that's none. So I say how many 6s go into 20. So that's going to be 3 with a remainder of 2. So then I say how many 6s go into 21. Well, that's also 3 with a remainder of 3. And then I say how many 6s go into 35. Well, that's going to be 5 with a remainder of 5. Right, so that's what I can say. So I can say I'm going to get an answer of 335 plus a remainder of 5. So therefore D is going to be 335 and R is going to be 5. So if I sub that into my equation, so what this equation means is that the 6 digits of 142857 is going to be repeating 335 times plus another 5 digits after that. So if I write a sequence of digits out again, so I'm just going to say that this is recurring at the start, and then I'm going to hit the first number, which is obviously going to be 1, then 4285, 7. So these are my 6 digits, and then I'm going to need the 5 digits that occur after these 6 digits. So it's going to be 1, 4, 2, 8, and then the 5th digit is not going to be 5, because what's going to happen is going to be my units digit, that's going to be my tens digit, that's going to be my hundreds, that's going to be my thousands, that's going to be my tens of thousands, so on. So my unit digit is actually going to get rounded. So the 7 is going to round the 5, which is going to give me 6. And then after here, it will keep on recurring. So that means that my units digit of n has to be 6. And I've got an answer for that, which is answer D. So therefore, answer equals D. Thanks for watching. Don't forget to subscribe. You can check out my other videos on this page. And also, if you've got any questions or any video suggestions, just leave a comment down below.